Hey guys, here's the spiral review for Spiral 8. Starting off with writing an equation for a quadratic. We are looking at, first off, my vertex, which is at -2, -5. That means I'm going to follow the form y is equal to a times the quantity x minus -2 squared, and then minus 5. And from there, I've got to figure out a. To do that, I'm going to plug in my other point. So 7 is equal to a times 0 plus 2 squared minus 5. I'm going to add 5 to both sides. 12 is equal to a, and 0 plus 2 is 2, squared is 4. That means that a is going to be 3, which leads to my equation. Y is equal to 3 times the quantity x plus 2 squared minus 5. I've been seeing quite a few people drop the squared. That doesn't make this a quadratic anymore. That would be a linear equation. And I've been seeing a number of people trying to do a slope here. That does not work. You cannot do that. You have to solve for a in this manner. Looking at graphing a quadratic, first thing I'm going to do is to identify my vertex. That's going to be at -2, 5. Cool. So back 2 up 5. There is my vertex. From here, I'm going to use my a value to go back 1, down 2, forward 1, down 2. And if I wanted to figure out some other stuff, maybe plug in 0 for a y-intercept. So we've got -2. 0 plus 2 is 2, squared is 4, plus 5, that'd be -8 plus 5 is -3. And we can pretty clearly see this parabolic shape coming out of this. Should be symmetric, so if you wanted to add a fifth point, -4, -3 would be there as well. I recommend 5 points on here so I can clearly see this is not supposed to be absolute value. And if you wanted to make a table to help me further see through maybe some graphing deficiencies, that would be helpful as well. Now we're moving on to factoring. So we're going to factor these things completely. I'm going to do the process out in full so that we can understand what's going on. There are a number of you who are not factoring using a method other than guessing, checking, or not factoring at all. This is a way for us to reconnect. So we've got 3x squared -8. Going to multiply those together. A times c is going to be -24x squared. I'm looking for things that multiply to -24x squared and also add up to that middle term. Okay, I'm going to start with -24 and 1, and -24 and 1 add up to -23. Nope, don't work. How about -12 and +2? -12 plus 2 is -10. That's really close to 10. Maybe if I rephrase that, instead of -12 and 2, I did +12 and -2, I can get to the values I need. Okay, that's what I'm going to break my middle term up into. So I've got 3x squared plus 12x minus 2x minus 8. I factor my first two. They've got a 3x in common. I'm left with x plus 4. I factor my second two. I can take a -2 out of both of these, and I'm left with x and a plus 4. Now I look and I see that they have an x plus 4 in common. I'm going to undistribute this x plus 4 and get x plus 4 out front. My leftovers are 3x minus 2. No guessing checking. No trying to figure out which ones will work for that factor of 8. This is a method that will get you from the beginning to the end without having to make any guesses along the way. Factoring again. I'm looking for things that will factor and multiply to 15x squared plus 47x plus 6. Okay, I'm going to take my first and last term, a times c. 6 times 15 is going to be 90x squared. looking for things that multiply to 90 and add up to 47. So multiply to 90 and add up to 47. All right, 1 times 90 gives me 91. No, 2 times 45. Oh, 2 plus 45 is 47. Pretty quickly we got to an answer. All right, 15x squared plus 2x plus 45x plus 6. Factor the first two. They only have an x in common. I'm left with 15x plus 2. Factor the second two. Divisible by 3. I've got 15x plus 2. Okay. Both of these now have a 15x plus 2. I can take those out and undistribute them into one parentheses. My leftovers are x and plus 3. This is my final factored form of this problem. Next up, we're going to factor some more, but this time we're going to solve by factoring. So it's going to start by factoring and take this to the next step. I'm going to begin these exactly the same way. My a times c is going to be negative 16x squared. I'm going to multiply to this and also add up to my middle term, so negative 15x. All right, I'm going to start again with 1 times negative 16, and hey, when I add those together, I get negative 15. That's the right choice. Nice, first try. 4x squared plus 1x minus 16x minus 4 is equal to 0. Okay? Factor the first pieces. They've got an x in common. I've got 4x plus 1. Factor the second pieces. I can take a minus 4 out of both of those, and I get 4x plus 1. Okay? Both of these have a 4x plus 1. That goes out in front, 4x plus 1. And my leftovers are x and minus 4. From this point, I can write 4x plus 1 is equal to 0. If I subtract 1 from both sides, divide by 4, I get x is negative a fourth. For my second one, x minus 4 is equal to 0. If I add 4 to both sides, I get x equals 4. We are solving by factoring again. Uh-oh, this one doesn't look quite right. Before I can even begin solving this thing, I have to set it equal to 0. So I'm going to add 5x to both sides. And I'm going to write this in order of decreasing degree, in other words, squared and then x and then number. So 2x squared plus 5x minus 3 is equal to 0. Okay, same process. 2 times negative 3. Negative 6x squared and add up to 5x. Okay, two things that multiply to negative 6 are going to be 1 and negative 6, but 1 plus negative 6 is negative 5. I want positive 5, so what if I switch this around? Negative 1, positive 6. If I do negative 1 plus 6, I get 5. That is the one I want. Okay, 2x squared minus 1x plus 6x minus 3 is equal to 0. First two terms have just an x in common. I get 2x minus 1. Second two terms I can pull a 3 out of, and I get 2x minus 1. I have a 2x minus 1 in common now. And my leftovers are going to be x plus 3. Solving this, 2x minus 1 is equal to 0. Therefore, x is a half. And x plus 3 is equal to 0. Therefore, x is negative 3. Continuing onward, we're now in the land of the square roots. Our goal is to solve this by taking some square roots. I'm going to start by trying to get the x squared piece by itself. Minus 36 to both sides. And I've got 9x squared is equal to negative 36. Divide both sides by 9, and I get x squared is equal to negative 4. If I take the square root of both sides, x is going to be plus or minus the square root of negative 4. I can't leave that like that. I could write that as the square root of 4 multiplied by the square root of negative 1, or plus or minus 2 times I. Okay, next up, we've got 40x squared minus 100 is equal to 0. I'm going to zoom out a little bit so we can see that 0. I'm going to add 100 to both sides. 40x squared is equal to 100. Divide by 40. I got some stuff canceling out. And I get x squared is equal to 10 over 4. Take the square root of both sides. X is equal to plus or minus the square root of 10 over the square root of 4, which is plus or minus the square root of 10 over 2. Five x squared plus 81 is equal to 0. I'm going to take a look at this by subtracting 81 from both sides. And we get 5x squared is equal to negative 81. Divide by 5. And I get x squared is equal to negative 81 over 5. Nice. Okay. I'm going to take the square root of both sides. We get x is equal to plus or minus the square root of 81 over 5i. I'm going to simplify this a little bit. Plus or minus the square root of 81 over the square root of 5i, which is plus or minus 9 over the square root of 5i. And if you wanted to rationalize that denominator, in other words, get that square root out of there, you could multiply this by the square root of 5 over the square root of 5, and you get plus or minus 9 square roots of 5 over 5i. All right, kiddos, welcome to Island. Get it? Because we're dealing with imaginary numbers, and it's island or island. We can go snorkeling in the morning. Okay, first up, the goal in this section is going to be to write things in the form a plus bi. We're going to have one that's a little bit different. We'll talk about that when we get there. But we're going to have to use the idea that I is equal to the square root of negative 1 in order to make some sense of these problems. All right, starting with 9 times 2 is 18. 9 times 7i is 63i. Negative 2 times 2 is minus 4i. Negative 2 times 7 is minus 14i squared. We know that I squared, in other words, the square root of negative 1 squared, is negative 1. So I could rewrite this as 18 plus, and then we've got 63 minus 4 is 59i. Minus 14 times negative 1 is negative 14. Oh, look, that's a positive 14 now. Okay, 14 plus 18 is 32, plus 59i. This now looks like that a plus bi form. Next up, you're being asked to rationalize the denominator by multiplying by a conjugate. Okay, in order to do this, I'm going to multiply the top and the bottom by something that will get rid of the I in the bottom. In this case, it's going to be the conjugate of this. In other words, the same thing, but with a plus between them instead of a minus. Okay, I'm going to multiply across up top. We've got 6 plus 4i. All right, and then plus 9i plus 6i squared. Cool. On the bottom, we're going to have 9 plus 6i minus 6i, and then minus 4i squared. Cool. Plus 4i plus 9i is 13i on top. 6i squared is the same as minus 6. those actually cancel out. That's kind of cool. On the bottom, my 6i's cancel out, and I've got 9 minus 4i squared. 4i squared is going to be minus negative 4. 9 plus 4 is 13. This actually comes out to just I is the answer. How cool is that? In standard complex number form, this could be written as 0 plus I. But I'm okay if you just leave I as the answer. Neat. Last up in this section is defining the absolute value of a complex number, which is not exactly a useful thing, but it's going to be on your midterm. So I wanted to make sure we talked about that now. In dealing with this, the absolute value of a complex number, and I'll talk about this as a plus bi, is defined as the square root of that first thing squared, a, plus that second thing squared. You might think this looks a little bit Pythagorean, and in fact, it is. So in this case, the absolute value of 7 minus 4i would be 7 squared plus negative 4 squared, or the square root of 49 plus 16, or the square root of 65. And that would be your final answer. Next, we're going to be completing the square to solve some problems. Back in the realm of non-complex land, which is fun. I'm sorry, not on an island. How many puns do you think I can do in one video? This one's already set up pretty good for us. My x squared is by itself. I don't have a c term to mess things up. I'm going to start by splitting up my b term. 5x minus 5x is equal to negative 12. Next up, I'm going to multiply these two pieces together. Negative 5 times negative 5 is plus 25. I'm going to add 25 to both sides in order to complete the square. X squared minus 5x has an x in common, x minus 5. I can take a minus 5 out of my next two, and I get x minus 5. On my left side, I'm going to have 13. My right side is going to continue factoring to x minus 5 times x minus 5. In other words, or in other symbols, x minus 5 squared. We have completed the square. Whoop, whoop. That's equal to 13. I'm going to take the square root of both sides in order to get my x by itself. So x minus 5 is equal to plus or minus the square root of 13. X is equal to 5 plus or minus the square root of 13. We've got to get that x by itself. Next, we've got 3x squared minus 21 minus 15. My 21x minus 15 is equal to 9. I'm going to clean this up first. I'm probably going to add 15 using the mosquito method to both sides. 3x squared minus 21x is equal to 24. Divide by 3, divide by 3, divide by 3. X squared minus 7x is equal to 8. Ooh, fractions. X squared minus 7 halves x minus 7 halves x is equal to 24 divided by 3 should have been 8. That doesn't look like an 8 to me. Now I'm going to multiply those two together and add that to both sides. So plus 49 over 4. I'm so glad I chose these numbers. Okay. And factor. X minus 7 halves squared is equal to 8 is 32 over 4. 32 plus 49 is going to be 79 plus 2 more is going to be 81 over 4. Okay. Then I'm going to take the square root of both sides. So I get x minus 7 halves is equal to square root of 81 is 9 over 4, so that's over 2. So 9 halves. And I get, adding 7 halves to both sides, x equals 7 halves plus 9 halves, and x equals 7 halves minus 9 halves. In other words, 7 plus 9 is 16, over 2 is 8, and 7 minus 9 is 2, over 2 is negative 1.